In my previous video, I already discussed about derivatives. This time, let us see the connectivity of the slope and derivatives. But what is a slope, by the way? So it has something to do with the rate. It is also defined as m in the formula y is equal to mx plus b. It is also defined as the rise over run in the Cartesian coordinate plane. And slope can also be written as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And it is also defined as the change in y with respect to x. And lastly, we can also write it as f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. So these are the definitions of the slope. So let us see the connectivity of the derivative to the slope. So for example, we have to look for the slope of this secant line. So in x-axis, since we have the coordinates x and y, let this be our x. And in our y-axis, let this be our f of x. And this point, since this is already x, we'll have this as x plus h. So in our y-axis, let this be our f of x plus h. And since in getting the slope, we have the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Then let this be our x sub 1 and this our x sub 2. And since we use the function, let this just be equal to the f of x sub 1 and this be equal to f of x sub 2. And since we want to know the slope of this secant line, using this, so we have our y sub 2 and y sub 1. So let that be f of x plus h minus f of x all over x plus h minus x. So this is now the slope of the line. But since we are looking for the instantaneous growth of this, then we will take the limit of this slope. And that is the limit of f of x plus h minus f of x all over x plus h minus x as h approaches 0. And so this is equal to the limit of f of x plus h minus f of x all over, we can now cancel x in our denominator. So that is all over h as h approaches 0. So now we can see that the slope and the derivative is very much connected. So here let us try to find the equation of a line tangent to f of x equals x squared at coordinates 2 and 4. And we know that we have the point slope formula, that is y minus y sub 1 is equal to m times x minus x sub 1, where our m is equal to our slope. So the first thing that we have to do here is to find for the derivative of our fx, which is x squared. So f prime of x is equal to the derivative of x squared, that is 2x. And since our x is equal to 2, then if we are going to find the f prime of 2, let's just substitute 2 in our x. So that is 2 times 2, which yields 4. So this is now our slope. So in order to get the equation of the tangent line, we will use the point slope formula. So this is the point slope formula. And since we have y sub 1, x sub 1 here, then let this be our x sub 1 and y sub 1. So y minus our y sub 1, that's 4, is equal to our slope, so that is 4 times x minus our x sub 1, that is 2. So y minus 4 is equal to 4x minus 8. So y is equal to 4x negative 8 plus 4, so that is negative 4. So this is now the equation of the line tangent to f of x is equal to x squared at the coordinates 2 and 4. And we notice that this is in the form y is equal to mx plus b, where m is equal to the slope and b is equal to the y-intercept. And we know that y is equal to mx plus b is what we call the slope-intercept formula. So if we are going to graph this, we know that x squared is a parabola. So if that's a parabola, so this is the parabola and this is our x and y-axis. And we know that a tangent line is a line that touches only or at exactly one point on a curve. So let's say this is our coordinates 2 and 4. So if this is the point, then this is the tangent line that touches the curve at 2, 4. And the equation of this line is y is equal to 4x minus 4. So that is the graph of the tangent line with an equation of y is equal to 4x minus 4.